Hello friends, welcome to Learner's Planet. Friends, I'm here with one more session on mensuration. So many students are still confused on this topic, so I thought let me take some more sessions, some more problems on mensuration. And once again, my suggestion is when the problem appears on the screen, just pause the session and try to do it on your own, right? Do not move further without trying the problems, okay? So let's begin the session, and yes, do attend the basic sessions of surface area volume before you come for this session, right? Okay, let's take this question. A metallic hemisphere is melted and recast in the shape of a cone with the same base radius as that of hemisphere. If h is the height of the cone, then okay. See, when you see the problem on mensuration, and when you see this 3D mensuration problems, do not draw the diagrams. If it is possible, then try the problem without drawing the diagrams. Right now, here what exactly is happening is a conversion of shape. Right, when one shape is converted to another shape, then volume remains same. I have explained this thing in detail in our basic session. Suppose you have a tumbler and you have 1 liter milk in it. If you just empty the entire milk in one pan, then the quantity of milk will remain same, right? So the shape of this milk will be changed, right? Shape of milk in the sense like maybe suppose tumbler is in this shape and the pan is in maybe in this shape, right? So here suppose the milk comes up to this level, and here suppose milk come up to this level. Okay, so this way the shape can be changed, but the volume of milk will remain same. So one shape, if it is converted into other, the golden rule is the volume will remain same. Important thing. Surface area will be definitely changed. You should be very careful about it. When one shape changes into another shape, surface area will be changed. Only the volume will remain same, otherwise all the things will be changed. Okay, unless until it is specifically mentioned in the question. Now here this hemisphere is converted into cone, and but the cone is also having the same base radius as the sphere was having, right? So we just have to find out the height of the cone. Now what is the volume of hemisphere? See, volume of sphere is 4 upon 3 pi r cube, right? So volume of hemisphere will be just half of that, that is 2 upon 3 pi r cube. Now as I told you, volume will remain same, so we'll equate volume only. So 2 upon 3 pi r cube, where r is the radius of this hemisphere, right? Now volume of this cone will also be same. Okay, so that is, what is the volume of the cone? 1 upon 3 pi r square h. Pi r square, we are taking same r because both of them are having same radius, right? Here it is actually capital R, I have written small r, that really doesn't matter, we'll take it afterwards. And h is the height of the cone, so 1 upon 3 pi r square h, right? Pi and pi is cancelled, 3 is cancelled, r square and this is cancelled, so h is equal to 2r. This is the relation that we are getting over here, so this is the correct option. So when one body changes into another, the volume will remain same, but surface area will be changed, right? In this particular question, we just have to calculate the volume. Surface area is not considered over here, but in any question, if surface area is considered, then just be very clear that surface area will be changed if a shape is changed to another shape. Okay. Total surface area of sphere is 8 pi square units. What is the volume of the sphere? Total surface area is what? 4 upon 4 pi r square. So 4 pi r square is 8 pi. So we want 4 upon 3 pi r cube. What is the volume? 4 upon 3 pi r cube. So for that we need to calculate radius of the sphere. So r square is equal to 2, that means r is equal to root 2. Now 4 upon 3 pi r cube is 2 root 2. So it is 8 root 2 pi by 3. Okay, pretty simple. Now we have this problem. ABCDEF is a regular hexagon of side 2 feet. Then the area of rectangle BCEF. A, B, C, D, E, F. We have to find out the area of this rectangle. Now you have two ways. Since you know this angle that it is 120 degree, either you drop a perpendicular over here, find this length, right? And double of this length will be this side of the rectangle. This is already 2, this is already 2. This complete angle is 120 degrees, so half of this will be 60 degrees. So this angle is 60 degree, this angle will be 30 degree in this right angle triangle. So we can easily calculate this length CP. It's a matter of seconds only using trigonometric relation. So relationship between this, that is hypotenuse and base, is given by cos theta. So cos 30 degree, that is root 3 by 2, is equal to this CP by 2. So CP is equal to root 3. That means this length is root 3, so double of that will be 2 root 3. So this is 2 root 3 and this is 2, so 2 into 2 root 3, it will be 4 root 3. That is the area of the rectangle. So that is very sweet and short method, so you don't have to go for a tedious process. Alternatively, what you can do is see, you know the area of the, it is just another method. It is a bit lengthy, but just for the sake of more clarity, I'm just discussing it with you. See, for this hexagon, actually it is a combination of 6 equilateral triangles. So area of hexagon is root 6 into root 3 by 4 side square. So this is what the area of the hexagon, right? From this area of hexagon, if you deduct the area of this triangle and this triangle, you'll be able to get the area of the rectangle. So what will be the area of this triangle? That can be calculated very easily. This is 2, this is 2. Using sine formula, we can calculate the area of CDE, and double of that, the same will be BAF. So just deduct it. So this is half of 2 into 2 into sine 120. Sine 120 is cos 30. Cos 30 is root 3 by 2. Okay. So area of this is root 3. Similarly, area of this is root 3. So from 6 root 3, 1 root 3 and 2 root 3, if we deduct, we are left with 4 root 3. So that will be the area of this rectangle, right? So various methods are there to solve the single problem. So must be knowing all of them. Okay, the volume of two right circular cone are in this ratio. Their diameters are in this the ratio of their height is. Okay, so volume ratio is 4:1. So 4 by 1. Directly write down the calculation, right? Do not waste time in writing down the formula. Now you know the volume of right circular cone is 1/3 pi r square h. Now 1/3 pi in numerator and denominator, it will be cancelled. So you are just left with the r square h in the numerator and r square h of the second cone in the denominator, right? Here the diameter ratio is 5:4. So radius ratio will also be in the same. So r1 square by r2 square is nothing but 25 by 16. So this is r1 square by r2 square, and that is h1 by h2, right? So do I need to tell you? It is 64 by 25, h1 is to h2. So hardly 20-25 second problem. And when you know the formula, do not write it, okay? Because that will be unnecessary wastage of space and time. Okay, the godown is 15 meter long and 12 meter broad. The sum of areas of the floor and the ceiling is equal to sum of areas of the four wall. What is the volume of the godown? So for that we need to find out the height. Okay, now for that see, length and breadth is already given. Now floor area and ceiling area, definitely it will be same. So that will be 15 into 12. So that is 2 into 15 into 12. That is the total area of ceiling and floor. Okay, now sum of areas of floor and the ceiling is equal to sum of areas of the four walls. Areas of the four walls, see, two walls will be having, you just can visualize it, length and height, and two walls will be having breadth and height, right? So it is precisely 2 times length into height plus breadth into height. Okay, I take h as common. So here it is L plus B, that is 15 plus 12, 27. Okay. So H is equal to 20 by 3. Now volume is LBH, so that is 15 into 12 into 20 by 3. So 15 into 4, 60 into 2, 1200 units. Okay, pretty simple. Water flows at the rate of 10 meters per minute from a cylindrical pipe 5 mm in diameter. How long it takes to fill up the conical vessel whose diameter at the base is 30 centimeter and depth 24 centimeter, right? So what we have to do, see, this is a cylindrical pipe and the volume in 1 minute, I suppose it will take n minutes, right? And volume of 1 minute is what? Pi r square h, where pi r is of this cylindrical is 5 mm, or I can say just 1 upon 2 centimeters. So it is 5 mm in diameter. So 1 upon 2 centimeter will be diameter. So radius will be 1 upon 4. So this is pi r square and h is 10 meter. Okay. So this is in centimeter, so I just write as in meter, meter into centimeter. So this is volume of 1 minute. So volume of n minute is this, right? And that should be equal to volume of cone. So cone volume is 1 upon 3 pi r square, whose diameter at the base is 30. So r is 15 into depth is 24. Okay, so precisely you have to calculate the value of n. Okay, here it is okay. So precisely n is equal to 15 into 24 by into 4 by 50. (24) into 2, 48, or into 3, or 24 into 3, 72 into 1 or 2, 144 by 5. So we'll get fractional value 144 by 5, that means 144 into 10 by 2 into 2 by, in fact divided by 10 into 2, 288, so 28.8 and 0.8, that means into 6, so 28 minutes 48 seconds, right? So 0.8 minute, that means 0.8 into 60, that is 48 seconds. So 28 minute 48 second. Okay. See this problem. A sphere of diameter 6 centimeter is dropped in a right circular cylindrical vessel partly filled with water. The diameter of the cylindrical vessel is 12 centimeter. If the sphere is just completely submerged in water, then rise of water level in the cylindrical vessel is. Now it's very simple concept. Initially maybe this cylinder is filled up till this level. See, in exams you don't have to draw the diagram. I'm just doing it for your clarity. Initially suppose it is filled till here, and because of this sphere, it is the level of water is up to here only, right? Rise up to here. So this is actually volume is this particular portion is nothing but the volume of sphere, right? So we can equate that. Now volume of this particular portion, it is also a cylindrical shape, right? So what is the volume of cylinder? It is pi r square h. So pi into r is what? R is of cylinder 6. So it is 6 into this height. I suppose this is h, and that is actually volume of the sphere. So it is 4 upon 3 pi r cube. R is 3. So it is 3 into 3 into 3. So we can calculate the height or the rise of water level, that is this level. Okay. So pi and pi is cancelled, 3 and 3 is cancelled. So h is equal to 3394 are 36 by 36, 1 centimeter. So the problem can be done in seconds. What you just have to do, the increased water level is just because of the sphere, right? So the increased water level, that is, it is in the shape of cylinder. So here it is volume of cylinder, and on the right hand side, because this volume is because of sphere, so we equated the volume of this particular water in cylinder to volume of sphere, right? So we get h. So it's a 30-second problem, and you don't need to draw the diagram, right? You can visualize the image in your mind, and that I would recommend. A copper sphere of diameter 18 centimeter is drawn into a wire of diameter 4 mm. The length of the wire is, okay, see, copper sphere, and on one side we have copper sphere, and on the other side we have wire. Now wire is nothing but a very you can say thin cylinder, right, but very small width. So here the width of the cylinder is nothing but 4 mm, right? Now once again a shape is converted to other shape, that means the volume will not be changed, right? So what we can do is we can equate the volume of sphere to volume of wire, right? Wire is nothing but the cylinder. Okay, so sphere's volume is 4 upon 3 pi r cube. So it is 4 upon 3 pi. R cube is diameter is 18, radius must be 9. So it is the volume of sphere. That should be equal to volume of wire, which is actually cylinder. So it is pi r square. R is 2 mm. So 2 mm, that means 2 by 10 centimeter. And that is the height of the cylinder. Height of the cylinder is nothing but length of the wire, right? This is a very thin cylinder. Okay, you just see this. It's very thin cylinder. Okay, so this is precisely length of the wire, or we can say this is, suppose this is the cross section. So that is radius of the wire, and this is length of the wire, or we can say height of the cylinder. Okay, now the problem becomes very easy. Pi and pi is cancelled. 3 3s are 9, 4. So height is 81 into 3, 243 into 10 into 10. In meter we have to find out, just remove 2 zeros, 243 is your answer. Pretty simple. So avoid paperwork and avoid lengthy calculations. Now, a tent is of the shape of a right circular cylinder up to height of 3 meter and then becomes a right circular cone with maximum height of 13.5 meters above the ground. If the radius of the base is 14 meters, the cost of painting the inner side of the tent at the rate of rupees 2 per square meter. Okay, see, again you just try to avoid this diagram, and just try to visualize it. On the here initially it is in the shape of cylinder up to height of 3 meters, right, and then becomes right circular cone. So the height of the right circular cone is nothing but 13.5 minus 3, that is 10.5, right? Precisely what we have to do, we have to find out the surface area of this shape. So surface area of this cylinder is 2 pi RH. So it is 2 into pi into R will be cylinder, this base, radius of the base is 14 meter. So R is 14. So 2 pi r and h, height of the cylinder is 3, plus that is curved surface area of this right circular cone, so that is pi rl. So in case this is 10.5, this is actually base radius is 14, so that we have to calculate. So I just see whether we get Pythagorean triplet. 14, 10.5, so it is this is 7 into 20, 7 into 15. So we have 20, 15 and 25 Pythagorean triplet, right? 20, 15 and 25 Pythagorean triplet. 3 into 5, 3 into, 3 into 5, 4 into 5 and 5 into 5. So 20, 15 and 25, they are Pythagorean triplets, so we will get 7 into 25. That is 175. So this will be 17.5. That is L. So it is pi into r is 14 into 17.5, right? And this into 2 we have to do. Okay. Now what we can do is, see, this pi is 22 by 7. So I write 22 by 7. 7 2s are 14. 22 by 7. 7 2s are 14. Okay. So this is 2, 5. Now since among the options we have one option that is a unit digit except 0. So we just calculate what is the unit digit of this calculation. So it is here 2 into 2, 4 into 2, 8 into 3, 24. Right? And here it is 5 and a even number. So unit digit of this calculation is 0. So final unit digit must be 2 into 4, that's 8. Right? So this way you can save some of your time. Unfortunately answers seems to be highlighted, but I'm just explaining the method how to get the correct answer, right? So if you have unique unit digits, then you can go by this method. Don't have to solve the entire problem. Precisely, you don't have to calculate everything, right? And apart from that, you can even go by the digital root method also, because you can see digital root of 2050, it is 2060, 80, all of them are different, right? So if you don't have the option of unit digit, then you can go by digital root method as well. Okay. Water is flowing at the rate of 5 km per hour through a pipe of diameter 14 cm into a rectangular tank which is 44. The time taken in hours for the rise in the level of water in the tank to be 7 cm. So precisely the volume in this tank will be 50 meter, 44 meter, and the height is 7 cm. So in meters it will be 7 by 100, right? 100 cm is 1 meter. It is this is the volume that we require. Right now we just have to calculate the total number of hours. So I assume it is n hours for this pipe to complete this, to fill up this tank completely. Now this is n. Now what is a per hour volume? So since this is a circular cross section, that means precisely it is a cylinder. So what is the volume of cylinder? Pi r square h. So that is pi r is 14 centimeter by 2, so 7 into 7. Now this is in centimeter and we are making calculations in meters, so divide by 100. So pi r square and h. Height for 1 hour, that is length for 1 hour, that is 5 kilometers. So it is 5000 meters. Okay. So nr, this is the volume of 1 hour that is coming out of this circular pipe. Okay, or we can say cylindrical pipe. Now the calculation is very easy. You can see n is equal to 2. So it will take 2 hours. Simple. So don't have to draw the diagram. Semi-vertical angle of a right circular cone is 30 degree if the ratio of numerical value of volume and slant surface is this. What is the radius of the base? Okay, semi-vertical angle, that means precisely, just draw. This is actually 30 degree. Right? Now if the ratio of numerical value of volume and slant surface area is 1:3, precisely V by L is slant surface area. Okay, V by pi RL, that means, okay, it's pi r square h by 3 pi RL, right? That is 1:3. Then we have to find out radius of the base. Okay, so this is radius of the base, this is slant height, and the relationship between these two, this is, if this is 30 degree, that is perpendicular and that is hypotenuse. So relationship between these two will be given by sine theta. So r by L is equal to sine 30, that is 1/2. So L is equal to 2r. Okay, so I just put up the value over here. It is r square into h upon RL is equal to 1. And we don't know h, so we have to calculate that also. H is this. So relationship between this and this, perpendicular and base, is given by tan theta. So tan 30 degree is 1/√3, that is r by h. So h is r√3. So this is r square into r√3 by r into, instead of L I can write 2r. Okay, and that is 1. R and this is r square. So r is equal to 2/√3, right? Pretty simple. Now a circle is inscribed in a square. An equilateral triangle of side 4√3 is inscribed in that circle. The length of the diagonal of the square is, okay, see what is happening over here. Suppose this is a square and the circle is inscribed in it. Now in this circle we have one equilateral triangle. So precisely this is the circumcircle of equilateral triangle. Okay, so what is the radius of the circumcircles? Radius of the circumcircle, r is equal to ABC by 4 area, 4 delta. Okay, so it is precisely, being an equilateral triangle, it is a cube upon 4, area will be √3 by 4 side square. So r will be a by √3, that is radius of the circumcircle will be a by √3. That means diameter of the circumcircle will be 2a by √3. So that is diameter of the circumcircle. Diameter of the circumcircle and side of the square will be same. So we know side, then we can easily calculate diagonal, right? So 2a by √3 whole square plus 2a by √3 whole square, that is diagonal square. Okay, so it is 4a square by 3 plus 4a square by 3. So 4 by 3, 4 by 3, 8 by 3 a square. Okay, that will be the diagonal square. I just put up the value of a square over here. It is 4√3. So 8 by 3 into 4√3. So it is 16 into 3. Okay, so this is 16 into 8 is a diagonal square. So square root will be 4 into 2√2, that is 8√2. Pretty simple. So I have already told you various times that you must be knowing the formula for circumradius and inradius. You will be able to use it. You have to use it in so many problems.